In this video, we will be discussing and explaining three fundamental syllabus dot points of Unit 1 Topic 1, Properties and Structures of Atoms. So the first point is to describe that atoms can be modeled as a nucleus surrounded by electrons in distinct energy levels. The second point we'll be covering is describe that isotopes are atoms of the same element that have different numbers of neutrons. And our third point will be explain that ions are atoms or groups of atoms that are electrically charged due to an imbalance in the number of electrons and protons. I am also displaying the definition of the cognitive verb used in each dot point to show what each point requires. Just note that I will not be covering the syllabus in sequential order, but I've done some reordering myself to introduce the foundational concepts before building on them further later on. So, we should probably already know what an atom is. An atom is an extremely small piece of matter that cannot be divided further without losing its chemical identity. What we need to know is that the atom consists of three types of subatomic particles: the proton, the neutron, and the electron. Now, I'll be representing the proton as a little red ball with a plus sign, the neutron as a white ball with like an N, and then the electron as a blue ball with a minus sign. Now, these sizes I've drawn don't actually represent their physical sizes. The proton and neutron are almost the same size, and they are a lot bigger than the electron. Now, we also probably already know that the proton, neutron, and electron have electric charges, and relatively speaking, the proton has a charge of +1, the neutron has a charge of 0, and because it's neutral, which is in the name, and the electron has a relative charge of -1. Now, protons and neutrons exist in the center of the atom, which is known as the nucleus. And the nucleus is always positively charged because it only has protons and neutrons. So if we take helium as an example, a helium nucleus has 2 neutrons and 2 protons. Now, in an atom, electrons surround the nucleus in distinct energy levels that look like, well, we represent them as these white circles. Excuse me if they're not super great. And I'll draw a third one. Now, helium only has 2 electrons, and they both exist in this first energy level. Now, we can explore later why they occur in the first level, but for now we represent the levels as like with n. So we have n equals 1, and n equals 2, and n equals 3. So right here, these 3 circles represent each distinct energy level. Now, for helium, we have 2 electrons that exist in the first one. However, in atoms, in any atom, electrons can move between these energy levels. So we could have this if this electron got some energy, it could move to the 3rd energy level. And then if it lost energy, it could move to the 2nd, and it could also move back to the 1st. But the important part I want to convey is electrons can only exist at these levels. They cannot exist between. So the last thing I want to talk about with regard to the atom is that the number of protons in an atom determines the element that the atom is. For example, an atom that contains 1 proton will be a hydrogen atom. An atom that contains 2 protons will be helium, as we have seen, and it goes on and on and on. Say, an atom with 6 protons represents carbon. So the number of protons in an atom kind of dictates the structure of our periodic table that we have, but we'll get into that in later videos. So what we've just talked about is that an atom, such as helium, consists of a nucleus, and which is then surrounded by electrons in distinct energy levels. Now, the nucleus usually contains protons and neutrons. However, not every nucleus contains neutrons, such as hydrogen, but all other elements will have some neutrons unless we're dealing with an isotope, which leads us on to our next topic. So the second point that we will be covering is to describe that isotopes are atoms of the same element that have different numbers of neutrons. So the point itself gives us the definition of an isotope. It is atoms of the same element which have differing numbers of neutrons. Let's use hydrogen as an example. I just said that hydrogen has no neutrons, but this isn't always the case. So if we go ahead and draw out what the hydrogen atom looks like, or a hydrogen atom looks like, we'd have our distinct energy levels, and then our nucleus only contains one proton, which is then surrounded by one electron in the first energy level. See, there are no neutrons, and we know that this atom is hydrogen because it only has one proton. So we just say H for hydrogen, right? But we can have another case of hydrogen, and if I can draw these circles quickly, we can see that again we will have one proton in the nucleus, but we can add a neutron, and adding this neutron does not disrupt the overall charge of the atom because the neutron holds zero charge, and it also does not change what element the atom is because it's not a proton. So this atom here is also an example of hydrogen, and we would say that this is hydrogen with a 2 up here because there are 2 subatomic particles in the nucleus, one proton and one neutron, and the other hydrogen we have has a 1 because there's only one proton in the nucleus. So as we can see, isotopes are atoms of the same element. So as we can see, isotopes are atoms of the same element but with a different number of neutrons. And because we are adding neutrons and not protons or electrons, the overall charge of the atom is not disrupted, and the identity of the atom stays the same. So we've just completed our second dot point and described that isotopes are atoms of the same element that have different numbers of neutrons. Now our third point is to explain that ions are atoms or groups of atoms that are electrically charged due to an imbalance in the number of electrons and protons. So we have ions. So we're going to use hydrogen as an example again, because hydrogen is, well, the most basic atom. So we take our model that we have already. We have one proton in the nucleus and one electron in the first distinct energy level. So currently in our model of hydrogen, we have one proton and one neutron. Now, we have previously described that the proton has a charge of +1 and the electron has a charge of -1. So the overall charge of our basic hydrogen atom is 0 because we have one proton and then we take away the charge of one electron, right? So 1 minus 1 is 0. So an ion is an atom that is electrically charged, which means the number of protons does not equal to the number of electrons. Otherwise, if they did equal to each other, the charge would be 0. So because ions are still the same element, we can't be adding protons because protons would change which element we have. So we have to either take away or add electrons. Now in the case of hydrogen, if we want to get a hydrogen ion, we're going to actually boot out this electron. So it's going to say goodbye. It's going to get what is called ionized, which makes sense because we're turning it into an ion. So if the electron leaves us, we can then be left with, excuse the poor drawing, just one proton in the nucleus with no electrons, and this is what we would call a hydrogen ion, which is represented with a H plus or H plus 1. And then we just have our standard hydrogen over here, which is with its neutral charge. Now, certain atoms have a tendency to either gain or lose electrons. We will go into the reasons for this later, but just keep that in mind. And we have basically covered the whole point, except there's a bit that also mentions that groups of atoms are electrically charged due to an imbalance in the number of electrons and protons. So this concept is not super important right now, but it will be more important later, where we basically get a group of atoms that are bonded together, and they can then have an overall charge rather than just the atom itself having an overall charge that's not zero. These groups of atoms that have an overall charge are known as polyatomic ions, which basically means many atoms, and the overall thing is an ion. But we will discuss them in later videos because they are not super important right now. So this brings us to the end of the video. Just to recap, we have described that atoms can be modeled as a nucleus surrounded by electrons in distinct energy levels. We have also described that isotopes are atoms of the same element that have different numbers of neutrons. And we have explained that ions are atoms or groups of atoms that are electrically charged due to an imbalance in the number of electrons and protons. I hope you found this video informative and useful. Please leave any feedback if you have any. Thank you.